Hey, what's up, you guys? It's Antonio Caritas back here with Lab 6. So we go in here, here's my Arduino code. On the setup block, I have the pin mode for the potentiometer read-in, the pin mode for the output that I'm going to use for my digital pulse width modulation, and I also have the serial begin just so I can start that and print that stuff. So anyway, here in our loop, I calculate like a actually, I don't need that anymore, but we can just forget about that. It calculates the potentiometer value from analog read of the pin 0, and then from that it converts it to get us a value in microseconds of how long it's supposed to be on. Right? So that was kind of like from the lab, kind of experimentally figured out those numbers. Also from the data sheet, but the data sheet was actually, I think, wrong. So they only gave me a 90-degree range of motion. So I just was able to extend it experimentally. And then if we go to, I print out a conversion from the potentiometer value by multiplying it by negative 180 over 1023. Of course, 1023 from the range of values that we can get from our analog read-in. And then I add 90 to that just so we have 0 as our starting point and go from negative 90 all the way to 90. And then I have it digitally write it to high, wait for that conval, that distance for that it's on, that's calculated above, and then I have it write to low, and then wait for the remainder of that 20 millisecond, 20,000 microsecond period that is set from my data sheet as like its cycle. So, alright, and then that's that. So I have it running right now actually. And you can see here I have it's currently just displaying 90 degrees, but I can go ahead and change that all the way up right there. Here's my Arduino. You can see my potentiometer, everything's wired up. Go ahead and move that, and there we go. You can see that's nice full range of motion. Yeah, and that's about it. So thank you guys.